vehicle with 400,000 kilometers on the odometer that has never had its engine opened. No rebuild, no major components replaced. Just fluid, filters, and timing. That is not a story. That is a documented outcome in Japanese commercial fleet management, and it happens often enough that Japanese OEM engineers designed entire maintenance protocols around achieving it as a standard result. Not an exception. The 5 practices you are about to hear are not products. They are not supplements. They cost nothing to implement beyond attention and a small amount of time. And the reason most drivers have never heard of them is not because they do not work. The foundation of Japanese automotive maintenance culture was not built for consumers. It was built for fleets. In the 1960s and 1970s, Japanese domestic commercial operators, taxi companies, delivery networks, light industrial fleets were running vehicles under conditions that Western service intervals were never designed for. High daily mileage, urban stop and go, humidity, and a market where vehicle replacement was expensive enough that extraction of maximum service life was an economic necessity, not an engineering curiosity. The result was a body of practical maintenance knowledge that spread from fleet engineering into the general Japanese domestic market through a culture of meticulous owner documentation. GS standards, Japanese industrial standards, formalized many of these practices into specifications that differ meaningfully from Western export market equivalents. That divergence is real, it is documented, and it is where this education begins. The first practice is oil interval discipline based on condition, not calendar. Western markets were sold on the simplification: change your oil every 5,000 kilometers or every 3 months, whichever comes first. That interval was engineered for convenience, not for the engine. Japanese domestic fleet practice has consistently used oil condition monitoring, visual inspection, cold start behavior observation, and mileage tracking against actual operating conditions, rather than fixed calendar intervals. Urban driving, short trips, and cold starts degrade oil faster than highway kilometers. A vehicle driven exclusively on short urban trips may need an interval shorter than the sticker says. A vehicle driven primarily on long highway runs may be changing perfectly functional oil before it needs changing. The practice costs nothing. Check your oil on the dipstick every 2 weeks. You are looking at color, viscosity, and level simultaneously. Black oil that still holds its viscosity on the dipstick is still doing its job. Gray or milky oil signals a problem that no service interval calendar will catch in time. Japanese fleet maintenance logs document this check as a standing weekly procedure. It is the single most information-dense 30 seconds of vehicle ownership. The second practice is coolant silicate monitoring. This is where JIS specification divergence from Western export standards becomes directly relevant to your vehicle. JIS K2234, the Japanese industrial standard for engine coolant, specifies silicate concentration ranges in inorganic additive technology coolants that differ from typical Western OEM export formulations. Silicates form a protective film on aluminum surfaces inside the cooling system. That film degrades over time regardless of the coolant's color or apparent condition. Western coolant marketing taught consumers to interpret green coolant as conventional and pink or blue as long life. That color coding is not a specification, it is branding. The actual silicate concentration in your coolant and whether it has fallen below the protective threshold cannot be read from color. Test strips that measure coolant pH and freeze point are available for under $10 at any auto parts retailer. Japanese domestic vehicle owners in high-mileage communities use them annually. The consequence of not using them is aluminum corrosion in the cooling system, a failure mode that is both slow and catastrophic when it arrives. The test costs nothing relative to a head gasket. The third practice is air filter inspection at every oil change. Not replacement. Inspection. Japanese fleet maintenance culture does not replace air filters on a calendar. It inspects them. A filter installed in clean highway conditions may have half the service life remaining at the mileage point where a fixed interval would replace it. A filter operated in dusty or urban particulate-heavy conditions may be severely restricted at half that same mileage. A restricted air filter causes the engine management system to run a richer fuel mixture to compensate for reduced airflow. That richer mixture increases combustion deposits, increases fuel consumption, and increases wear on oxygen sensors and catalytic converters. Removing and inspecting an air filter takes 4 minutes. Hold it up to light. If light passes through the filtration medium evenly, it has service life remaining. If it does not, replace it. This is not advanced. It is documented in OEM technical service manuals that most owners never open. The filter is a primary gating component for combustion quality, and combustion quality governs everything downstream. You now understand something that the standard service checklist was never designed to communicate. Not because of conspiracy, because checklists are simplified for efficiency and consumer accessibility, and simplification always has a cost. If this is useful to you, subscribe and share it with someone who owns a vehicle. What comes next is the practice that Japanese fleet engineers identify as the single highest leverage-free habit in long-term drivetrain preservation. But stay here because the mechanism is not obvious, and when you understand it, you will never skip this again. The fourth practice is cold start idle discipline. Tribological literature, the science of friction, lubrication, and wear, consistently documents that the highest wear period in any engine's operating cycle is the first 30 to 90 seconds after a cold start. Oil pressure must build from zero. Oil film on bearing surfaces has drained partially during the cold soak period. Metal clearances are tighter at cold temperature than at operating temperature. The combination of low oil film thickness and high mechanical friction during this window accounts for a disproportionate share of cumulative engine wear over the vehicle's service life. The Japanese fleet practice derived from this reality is simple. Do not apply load to a cold engine. This does not mean idling for 10 minutes before driving. Modern fuel-injected engines do not require extended warm-up and extended idling wastes fuel and increases deposit formation. It means driving gently at light throttle and low RPM for the first 3 to 5 minutes of operation. No wide-open throttle. No high RPM acceleration. Allow oil temperature and pressure to stabilize before demanding performance. This practice is documented in Japanese domestic market owner manuals with more specificity than Western market equivalents and is reinforced in fleet operator training materials. It costs nothing. The wear reduction over 200,000 kilometers of consistent application is not marginal. The fifth practice is transmission fluid clarity monitoring. This is the most neglected fluid in Western vehicle maintenance culture. Automatic transmission fluid degrades thermally, and the consequences of operating a transmission on degraded fluid are almost exclusively discovered after the failure has begun, at which point the repair cost ranges from several hundred to several $1,000s. Japanese fleet operators running high-mileage automatics treat transmission fluid condition with the same discipline they apply to engine oil. The check is simple. On vehicles with the transmission dipstick, consult your owner's manual. Pull the dipstick after a short drive with the transmission warm. The fluid should be translucent red to light pink. Dark brown fluid with a burnt smell indicates thermal degradation. Black fluid indicates advanced degradation. Foamy fluid indicates water contamination or overfill. Any of those conditions warrants a fluid service before the next scheduled interval, regardless of what the calendar says. On sealed transmissions without a dipstick, the monitoring approach shifts to behavior. Hesitation, delayed engagement, or hunting between gears are early indicators, and a trained independent specialist can perform a fluid extraction and inspection. The fluid is your window into the transmission's internal condition. Japanese fleet maintenance culture keeps that window clean. The total cost of all 5 practices, a $10 pack of coolant test strips. One time. Everything else is time and attention. We are talking about 20 minutes per month of deliberate observation, the equivalent cost of the failure modes these practices prevent. A cooling system repair for aluminum corrosion, $800 to $2,400 depending on severity. A transmission service deferred past the point of fluid degradation, $2,500 to $4,000 for a rebuild. Combustion inefficiency from a restricted air filter over 40,000 kilometers, measurable in fuel economy and sensor replacement. Cold start wear accumulated over a vehicle's service life, expressed as reduced compression at high mileage, and the timeline to your first major engine decision moved forward by years. None of this is hidden research. It exists in JIS documentation, in OEM technical service literature, in the professional maintenance records of fleet operators who have been running vehicles past 500,000 kilometers for decades. The gap is not between what is known and what is true. The gap is between what is documented in engineering literature and what reaches the person standing at the fuel pump. These practices were not invented for consumers. They were developed by engineers and fleet operators solving a real economic problem. How do you extract maximum reliable service life from a mechanical system operating under real-world conditions? The answers became embedded in Japanese domestic maintenance culture across the 1970s and 1980s. They traveled with the engineering reputation of Japanese vehicles into global markets. But the specific practices behind that reputation largely did not make the same journey. You now have them. They cost nothing to implement starting with your next drive tomorrow morning. If this channel is useful to you, subscribe now. Share this video with one person you know who is driving a high-mileage vehicle and paying for problems that earlier attention would have prevented. They need this information before their next service appointment, not after it. Next video. Why the viscosity grade printed on your oil cap may not be the grade that best serves your engine at its current mileage, and what the OEM technical literature actually says about viscosity selection as engine clearances change over time. That is information your service advisor has access to and is not required to explain to you. We will explain it. Come back for that one.